And we begin. Okay. That's fine, gotcha. Alrighty, so the first thing you're going to do is you want to go to your places, right? Go to your places where you usually store your files. Alright, I don't have places on here, so I'm going to do some of my weird stuff. Go to your regular places. Alright, now, let's see. Alright, so my stuff is here. Alright, so you should see all your stuff from chapter 1, 2, 3, all that stuff, right? Is everyone there? Are you there? Okay. Everyone can see their files? Okay, Chris, you waiting for something? Yo, Hastings. Today? Log in. Okay, Anthony, can you exit out? We're not doing that? Okay, you guys in? Good, all right. Now, make a new folder. Let's call it LACS. I like to call this Life After Computer Science. LACS. Now, go into that folder, and guess what you're going to do? See this thing on your desktop? Do you see it? Everyone has it on their desktop, right? Okay, right-click it, copy it, right-click over here, and paste it. So you can use it. Or drag it, same thing. Okay? I just SCP copied this from my machine to everybody's desktop, so you can copy it there. Huh? Secure copy? It's like shush, but for copy command. All right, so everyone has that folder and everything, right? Okay, let's write a program.
Where do you want it? New folder?
I made a new folder called LACS, Life After Computer Science. Yeah. Okay, and then you put it in there. All right, so everyone has this, yes? Okay, so let's make a tester class to show you how this graphics utility file works. All right, so let's make a new document, make it an empty one.
Tester.
I'm going to call it Polar. How about PolarTester.java? Now, I'm not really testing Polar. I'm going to do a Polar graph, and I'm testing the graphics .jar file that I gave you. All right, so everyone got this? All right, let's open that up, and let's write some code. Here we go. Okay, so wait, hang on. Where's my size here? Fonts. This font is way too small. That's probably good. All right, fine. All right, so here we go. Let's start from the top. What do we usually do? Header comment. So / ***. What's the first header comment usually? All right, the name of the file, Polar. We're going to do some Polar graphing. You ever do Polar graphing on your TIs, TI-83s or something? PolarTester.java. Put in your name. And we'll be printing some of these out for a grade, so let's make this correct here. And 2012, what's today, the 29th? Yes. Okay, purpose. What's our purpose? What do you think I'm doing? I'm going to test graphics.jar by making polar graphs. How about this? Yay. Okay. How about required files? What do we need? We need PolarTester.java. And that's the main class, right? And I'm going to need graphics. In the same folder, we have it, right? Graphics.jar. And this, I'll call this a utility class. Yeah. Utility classes. There's actually several graphics classes in there. Alrighty. What's the next line usually? First. Translator. All right, so this is what we're going to do. We're going to say Java C. Now, how do you use the jar file, remember? It's that long thing, dash, class, path. You have to include the current folder, there it is, dot, colon, and the file, dot / graphics, dot jar, and then the name of the file that we're translating, which would be PolarTester. All right, and what's the interpreter line then? Remember, it's almost the same. What's the only difference? No C, no .java. Right, okay, good. All right, so has everyone got the header comments so we know what we're doing? All right, so what's the first real line of Java code? Public, yep, class, Polar, tester. Okay, and then? Public, static, void, main, string, array, args. Everyone?
Or can that change sometimes?
Yeah.
If you run it in IDE.
Well, we're not doing that. Yeah, I try to keep a minimalist setup. The IDEs get to be very complicated. Eventually, I'm going to get into Eclipse stuff for Droid application development. So, yeah, I'm going to have to do that. Okay. All right. So there's your main. Now, what I'm going to do is I'm going to set up my graphing window. All right. Now, remember on your TI-83, don't you usually set up an Xmin, an Xmax, a Ymin, a Ymax in your graphing window? You can change that if you need to, right? Anyone there? Anybody hearing me?
You're not doing that, we're going to Polar.
I know, but I need to set up a window.
Right.
All right.
Or in Theta, not X.
Yeah, okay, but yeah, I'm going to do it actually parametrically. I'm going to graph it in as X and Y. You'll see. Hang on. All right, so what I'm going to do is I'm going to set up an Xmin, an Xmax, a Ymin, a Ymax. It's a little window I can graph on. It sets up like a little piece of graph paper for you, okay? So let's do standard draw. Standard draw is a static class that's built in the graphics.jar file. Okay, is that, can you see that? We okay with seeing that? Yeah, okay. Standard draw dot, it's, standard draw is proper, and set X scale is not really camel because scale is not capitalized. All right, so I'm going to set the X scale. Do you see that? Okay, let's say an X min of -1 and an X max of +1. The positive is probably optional, but just to make the point. Okay, there you go. All right, and then guess what else I'm going to set? The Y scale, right. So standard draw. Remember, if it's a static class, you don't have to construct it to use it. We're not using, standard draw bob equals new standard draw, and then bob dot set X scale. We're not doing that. It's like the math class, right? Math dot squirt, standard dot X, set X scale, right? So set Y scale. And let's do that from -1 to 1 also. All right, so that just sets up my window. All righty? All right, now, what I want to do is graph 3-petaled rows. Do you know how to do that? Do you know the polar equation for the 3-petaled rows? You ever do polar? R equals sine 3 theta? That would be a good one, right? Okay. All right, now, does that go through the origin? If you graph it on X and Y, does it go through 0, 0? It does, right? Okay, so I'm going to start there. I'm going to set double x0, my first x value that I'm graphing. I'm going to start at 0. And double my first y value, let's call it y0, starts at 0. And then what I want to do is plug in a whole bunch of angles into R3 theta. How am I going to plug in a whole bunch of different thetas into R equals sine 3 theta? So what I want to do is I want to draw this point, 0, 0. You're going to use math.sine, right?
And you probably need to convert into degrees or
If you want to use degrees, you can do that. You can convert to radians using the math class. I'll show you. But if I want to actually plug in a whole ton of points, say from 0 to 360, right? 0 to 360, I could use a list. Or just a plain old loop, yes? So set up a loop. Here we go. 4. Okay, now what do you think I need here? I want to go from 0 degrees to 360 degrees. Well, is it an int?
Well, are we doing it? We can't do it for every single value.
Right, but we're going to do it for more than just the ints. How about double? T short for theta starts at 0.
How are you doing?
You'll see. And then T is less than or equal to what? We said we're going to go from 0 to what? Yeah, that's a double. So 360. I'm just making the point that it's a double.
Or we can do it to 2 pi.
Well, I'm going to stick with degrees since you said degrees, so I'm doing that. All right, and then how am I going to increment T? T is theta, in other words.
Well, I was going to go by plus 1.
Yeah, but how about plus equals 0.1? Let's get a whole ton of points. See, what I want to do is I want to graph a whole ton of points. So they're so close together that it looks like a smooth curve when you graph it.
It looked like a smooth curve when you graphed it. You did it for 1 place.
For 1 degree at a time? I don't know. We could try that. We'll find out, okay? But I wanted to have a whole ton of points, okay? Now, what do we do in the for loop? None of this, by the way, none of this has to do with standard draw yet, except for the window, right? Setting up the window. I'm just doing math stuff. I'm doing Java and math dot squirt, that kind of stuff, right?
You do the R value and the sign value that you solve for X and Y.
Okay.
And then you're going to plot them using the graphics.
Right, exactly. So remember that parametrically, you can graph X equals R cosine theta and Y equals R sine theta. Do you know how to convert between polar and Cartesian?
Yeah.
From X and Y to R theta, you know that stuff?
Yeah.
Or I'll explain that in a little bit on the smartboard, but let me put this in. So let's say I want to make theta, now the thing is this, I'm going to use math.sine, right? And the problem with math.sine is it needs radians as input. So how am I going to convert this to radians? These are degrees, aren't they? These T values?
Times 2 pi divided by 360.
Yeah, that would be too easy. How about this? You could do that. But I'm going to do this. Ready? Math dot 2 radians. I bet you didn't know about that function, did you?
Wait, math dot what?
2 radians.
That's a...
There is a math function like that, yes.
What?
Yes.
I can see this.
Yeah, math dot 2 radians. I'm not making this up. Yeah, you can't see
Oh,
it?
2 radians.
2 radians, 2
I
radians.
thought you meant TW.
No. Don't get crazy now.
Okay,
That's
okay.
getting crazy. Wait, this is a little bit small. Let's fix this again. Make it 20. There you go.
So
How's that?
the math dot sign of math of 2 radians.
All right. Now, what I'm graphing is this. R equals sine of 3 theta, right? So how do I write sine of 3 theta? Math.sine, right. And let's say 3 times theta. Now, I already converted theta from degrees 0 to 360 to radians 0 to 2 pi. Well, because I wanted a 3-petaled rose. Isn't that the 3-petaled rose? Sine of 3 theta,
Oh, okay.
right? And it'll have
So
what?
the sign of math, sign of 3 times math dot 2 radians. Yeah, okay.
Oh, you want to put it all in one line? You can do that. Okay. Actually, you can't do that because what I'm graphing is this. Ready? I want to go from the point x0, y0 to the point x1, y1, and in fact, I'm going to draw a little line between each set of points. So I'm going to calculate x1, the next point, is going to be r times math dot cosine of theta. Remember, you can convert to x and y by taking r and multiplying by cosine of theta to get x, and r times sine of theta to get y. You guys didn't do polar mode yet in math class?
And then y0 is sine.
Well, y1. So I'm going to graph y1, x1, y1. So here's
We
y1.
can't do that. We haven't declared them.
Yeah, I am declaring it in the loop. Double. So r times, so I have, so far in my loop I have 4 doubles, right? I have theta, I have r, I have x1 and y1, yeah. I do, where? Right here? Whoops, yes I do. All right, so what's missing here, anyone? How do you convert to y from r? Times sine, right. Okay, so r times math dot sine of the same theta. Okay, and now here's the drawing part. It's very simple. You ready? Standard draw dot line from x0, y0 to x1, y1. And the point is this. It's not really much of a line. It's very, very short because I made my theta step very, very small in degrees.
Standard draw dot.
Dot line. The standard draw class, really what it does is it lets you draw things like points, lines, circles, stuff like that, okay? All right, and so it'll draw one line, but is that what you want? That only draws the line from x0, y0 to x1, y1, from 0, 0 to the first point.
Well, now what we do is we set x0 equals x1.
Right, so let x0 become the new x value, x1, and y0 become the new y value, y1, and do the whole thing all over again, and it'll graph a line from there. So it'll really be graphing from x1, y1 to x2, y2.
So you'll never actually get the graph. You'll just get a really, really good approximation.
It's a good approximation. Yeah, it's pretty smooth, though, because of my theta step, my plus equals 0.01. All right, so does everyone have the main? That's it. That's all there is to it. Simple. All right, save it. Well, if you want to try one, see what it looks like, go ahead. All right, so are you ready? Are you ready to test it? Shell out?
Shell out, shush in.
Don't forget to shush in with the dash capital Y. We're doing graphics. Just like we did with Grid World.
Yes.
Standard, yes. You had to bring that
I
up.
missed that too.
Yeah.
I thought it was all the way written out as standard.
Yeah, it's not a disease, it's an STD, I know. Yes, thank you, that was funny. All right, so let's go to shell. And let's shush in with the dash Y. See the dash Y? Remember the dash Y we needed for Grid World to see the graphics?
Where is it?
Okay. And hopefully it'll ask for your password someday. Come on today.
I'm not getting an std.set.
Wait, hang on. All right, now make sure you're in the right folder. I'm going to CD, let's see. Zoom. I'm going to CD to LACS.
Set x scale, right?
Okay. All right, so if you look in your folder, all you have is graphics.jar and PolarTester.java, right?
Yeah. And
Okay.
mine does not like
So,
like this.
this is what you do. Java C dash class path space dot colon dot forward slash graphics dot jar polar tester dot java. Whoop, what'd I do?
No, I don't believe it's a dash slash.
Wait, what'd I do? What'd I do? Wait, I did something silly. I did this yesterday, and it worked fine at home, so hang on. I'm missing something stupid. Can I find symbol standard draw?
Is it have to put spacing?
That's really weird. This worked perfectly the last period I was playing with this. I called it rows, but that's not the issue, is it? Standard draw dot set x scale.
That's exactly what my problem is.
I can't find standard draw, really? It's not finding graphics.jar. Did I spell it weird? Graphics.jar. What if we just did this? No. Graphics. This worked perfectly like 5 minutes ago.
Go back up to what you had with rows.
Why? What about it?
See if you did it exactly the same way.
I did. Except for I don't have any args input. That's later. Well, the only thing is I didn't set a pen color. So what the hell does that matter? It can't find standard draw. That's the problem.
No, I mean go back to the command you used for rows.
Yeah, well, that was in a whole different folder.
You can't do that with the up arrow?
Yeah. It should be in here somewhere. There's a whole ton of other junk going on.
Oh, you had to do that for
Yeah, I
each
had to
one
do
of
it for
your
every
symbols.
machine. That. There's nothing different there, except for,
You
well, that's a
put the
Java.
space in the different.
No, that's a Java. Where's the Java C? Where's the Java C? Exactly the same thing.
Well, I don't know. Maybe it would fix mine. I put the space in the wrong place.
What space? Where?
I did not put a space there.
Yeah, but I think I have that.
That's interesting.
That's weird. Hang on. Did anyone get it to run? No, no running? Okay, hang on. I know this works because I've been playing with this all weekend. Let's see, hang on. Java C dash class
Are you sure
path
STG is the
Yeah, it's right. I have it run. I have this file was running. It's exactly that. Okay, class path, current folder, colon, current folder graphics, .jar. Okay, and it was PolarTester.java. I can't find it. Why?
You need to like install graphics somewhere.
No. It was just this file.
You just copy paste that jar file into that place.
Yeah. Look, I'll show you. I did it over here. If I cd, let's see.
There's so much stuff.
Okay, here I have it, but I called it rows.
I don't know. I can't find an STD in graphics.jar. No, here it is.
There it is. See, I just switched folders and it works perfect. That's weird.
No, there is no. I can't find an STD. I can find an STD array.
That's weird. Look, here I have it running in a different folder. Wait, well, this one I inputted the 3. See, look, here it is. You see it? There's my 3-leaf rows.
Cool. I can read all the source code now for all of Draw.
Oh, it's in there?
Well, I went through a bunch of folders to find the library for Draw.
All right, so there's the 3-leaf rows. Why you can't get it to run, I don't know. The only difference is I downloaded this file directly from the net, and you didn't. You copied it from the desktop. Did you maybe get a copy error?
There's no standard.
I know, that's the problem. Look, I'm using the same file, graphics.jar, in a different folder. It works fine. But this graphics.jar, I copied straight from the net. No. So the only difference is you copied it from the desktop. Did it get copied wrong? That's what I'm wondering. I think about this. Wait, hang on. Let me do this. ls-l. No, clear that. ls-l star.jar. All right, my graphics.jar is 311 megabytes. How big is yours?
Yep. 31184.
Oh, so it did copy correctly. So what the heck is the problem? You want to fix this? Well, it worked fine. It works fine in this folder. Why doesn't it work in the other folder? All right, the only difference between this program and your program is that I have args input for the number 3. Because as you know, all right, let's see if you know this. What if I made it 4 theta? What happens? Excuse me, Mello. Excuse me, Mello. Did I tell you to get rid of that? Jade? Get rid of that. Okay. What happens if I don't graph sine 3 theta and I graph sine 4 theta? Does anyone know? It doubles, right? So you get 8 petals. All right, so I have this set up so that I can input the number in front of theta. This is polar graphs. You never did polar graphs?
No, we did it, but I don't remember.
You remember doing this?
Really?
All right, what if I run it for 4? You should see 8 petals, right? Let's see. There's 1. And there's 2. And it's going to take a little while, but... All right, we have to figure out why this isn't working in your folder, and it's working in my folder. That's weird. There's 4.
Oh, I found one of my errors.
There's 5.
Not the right one, but...
There's 6. Why is it so slow, by the way?
Because you're graphing so many points.
Because I'm graphing a gazillion points, right. I'm going from 0 to 360 in 0.1 increments. So that's 3,600 points.
See what happens if you do it with 1.
All right, let's do that. All right, so All right, so if I...
Switch back across to where your
Yeah, where's my stuff? Where's my stuff?
You really need to use other workspaces.
Yeah, I hate that. This is it, right? Okay, so if I go...
Workspaces.
Because I'm used to this.
Really?
Yeah.
So long.
Okay, what was I going to do? Oh, rows, right. So rows... That was rows, there it is.
Every time I ask you for another file, you have to go over here, find it, click around. I just make
Right.
a mouse click.
All right, so you want to just go 1 degree at a time?
Yeah.
All right, save it.
Alt tab or
Whatever. All right, so let's Java C it. Do I have a Java C in here? That's a little faster. All right, so that's only 360 points. It's still pretty smooth. Yeah, okay, that's fine.
I think you could do it up by like 5.
Yeah, but when you get a lot of pedals, I think it gets crazy. Let's see. Here's 4. Not too bad.
Try it for yeah.
It's a little bit, you can tell it's not smooth, but how about...
It's still a great increase in performance.
Yeah, well, of course. There you go. There's 8. Okay. So that's sine
16 of
8
I don't know that.
theta, so there's 16 pedals. Good, that's
I don't
fine.
know. 16 pedals. It still looks pretty smooth with 1 degree.
All right, so
at a time.
that's not bad. I expected it to be worse.
On the TI.
Yeah, that's why. On the TI, it's terrible, right?
We grab like 5 at a time. It's still slow.
Yeah.
And we still get decent results.
All right, save what you got. We'll fix this tomorrow. I don't know why you can't get graphics to work. If we have to download it straight from the website that I got this from, maybe that'll fix it. I don't know. We'll see. All right, so just save it, and we'll take it from there tomorrow. All right, bye-bye, YouTube. Where are you, YouTube?
Get that. It's like,
Bye-bye.
it's like a sound effect. The, you
What?
won a battle in Final Fantasy.
Oh, yes. Okay. Why is this not ending?
You're
Ugh.
moving.
Yes. All right. So tell it to just restart. It'll save it. Ta-da. All right, so fix that tomorrow. It's probably a download error of some sort.